Good morning, dear students. I am Dr. Batri Srinivas, Professor of Chemistry in St. Peter's Autonomous Engineering College. Today, we are going to discuss the external treatment of water. So, before going to discuss, what I explained in the last class, what I explained, what we have discussed in the last video, the internal treatment of water. We have discussed the internal treatment. Today we are going to discuss the external treatment. But last class is the internal treatment of water. In that, what are the methods we have discussed? We have discussed the Colgan method, phosphate conditioning, Colgan conditioning, colloidal conditioning. We have discussed in the last class. In all these methods, we added chemicals. What? We added chemicals in that method. Colgan method, we have used chemical. Phosphate condition, we have used the method to purify the water. So, today we will discuss the external treatment of water. That is our topic. What is that? External treatment. External treatment of water. This is our topic. Today we have to discuss why we are using question, why we are discussing this topic. In the last class, what we have discussed, the phosphate conditioning, corrugate conditioning, colloidal conditioning. In that, we have used chemicals. But in this, we are not using the chemicals. Just we have to use it as external, that is resins we have to use. So, actually, the external treatment of water, there are two types are there. That is, one is the zeolite method. And second one is the ion exchange method. Ion exchange process. Let's say process or method. Process. These two topics are useful, very useful for the purification of water by external method. Okay? So, in the last class, internal treatment, today external treatment. External treatment outside. Now, don't add any chemical directly into the water. So, what is this process? What are the key points in this method we have used? What are the key points? First of all, what is that? We have in our syllabus, it is not there. Only we have to discuss ion exchange process. Okay? External treatment of water. What is that? Ion exchange process. Ion exchange process. This is our topic. In this what we have to, the main key points we have to solve. Main key points are only 5 are there. They are what? First of all, we have to know about resin. First point is what? Resin. In the second point is cation exchange resin. Cation exchange resin. And third key point is anion exchange resin. And fourth one is process ion exchange resin. Process. ion exchange resin. And fifth one is the regeneration of resin. Regeneration. Regeneration of exhausted resin. Exhausted resin. So what we have to do? Regeneration of exhausted resin. So exhausted resin. So what are the key points we have to discuss? First we have to know the resin and cation exchange resin, anion exchange resin, process and regeneration of exhausted ion exchange resin. So these are the main key points. We have to write completely. It will come for 8 marks question. It's a long question. Sometimes 2 marks question will come. Sometimes explain 3 marks, resin plus cation. Sometimes draw neat diagram with process ion exchange, 6 marks. Come or 3 marks only regeneration of eggs or complete process. It's a very, very important topic for engineering level. 90% it may come in the examination. We have to listen carefully and read. If you listen carefully, then it's a very easy topic. Once you have to listen, we can understand. Then without reading also we can write. One diagram, the process diagram is very, very important in this cation exchange resin diagram, anion exchange. Okay, now first we will see the resin. Okay, so what is meant by resin? What is resin? The first question is, what is resin? Ion exchange resin are cross-linked long chain organic polymers with microporous structures. What is that? Cross-linked. So, for example, ion exchange is like this. Resin is like this. This is the resin. This is resin. Resin is look like that. But in this, what is there? Cross-linked long organic polymer with microporous structure. What is that? What is that? For example, this is the resin. Long chain organic polymer like this. And cross-linked. This is the cross-linked. And this is the long chain. Long chain polymer cross-linked having the minus ion place. Like this. These are the functional groups. So this is about the resin. Resin is like what? It's a long chain organic polymer with having a microporous structure. The functional groups attached to them. Functional groups are attached to them. So the functional groups are responsible for the ion exchange properties. If negative is there, it's a different property, and positive is there, different property. So what are the positive and negative? So the positive is what? And negative. There are the two types. cation exchange resin and anion exchange resin. Positive is the what? Cation and negative is the anion. Anion exchange resins. So this is about the resin. So resin is a definition, simple diagram. Okay, what are the type? Cross-linked, long chain, organic polymer with micropore structure. Micro, small pores. So small pores are there. So long chain, cross-linked and having function group. These three key parts in the resin. Long chain, organic polymer, cross-linked and function groups. This is about the resin. Okay. So resin. So next in this, what is their functional groups are? What are that? Cation exchange resin and anion exchange resin. What is that? Cation exchange resin and please draw it. Note down. Next topic is what? Cation exchange resin. Cation exchange resin. Resin is having an acidic functional group. Resin having an acidic functional group is capable of exchanging their H plus ions. So exchange the H plus ions with cation responsible for oddness. Cation responsible. So cation, for example, sodium sulfate is there. Sodium sulfate, Na2SO4. In this is the plus 1, this is the minus 2. So in this is the cation, this is the anion. So this is the oddness of water, oddness responsible compound, sodium sulfate. So sodium is the cation and anion. So what will happen? This cation exchange resin take the anions, cation, and release the H plus ions. Release the H plus ions. Take the Na plus. So that is main important. Resin is having an acidic functional group which is capable of exchanging their H plus ions with the cation responsible for oddness. These are mainly, what is that? Mainly styrene divinyl benzene copolymer. What is the name? Styrene divinyl benzene copolymers, which upon sulfonation or carboxylation is capable of exchanging their H plus ions with oddness producing ions in water. So example, Dovex, Amberlite IR20. So examples are what? Example, Dovex, Amberlite 120. So these are the cation exchange resins. These are the cation exchange resin. If you want structure, I will draw it. Okay? You also note that one. So what is the cation? Benzene, styrene divinyl, mean this is the styrene. For example, we write this structure, this is the benzene, CH2, SO3 minus H plus, like this. So this is the structure SO3H plus. So here what happened? This is the long chain. Long chain, this one. So it will get on upon long chain. But what is the functional group is there? SO3H plus ion. SO3H plus ion. What is that? SO3H plus ion is a strong acidic functional group. Strong acidic functional group. Strong acidic functional group. In this this what is there? H plus ions are there. When treatment with the cation, water is passing through the resin, so what happens? This H plus ion is released and cation is taken. That is the reason it is known as the cation exchange resin. Cation exchange, H plus cation, Na plus cation. Cation exchange resin. Understand why the name is cation exchange resin? Mean only cation. One H plus is a cation, sodium plus is a cation. H plus is going and Na plus is coming inside. So this is called the cation exchange resin. Okay? And now cation and exchange resin is understood, that one. Just only H plus ions are exchanged by sodium plus ion. So that is the cation. So what is the name? Benzene, styrene, divinyl, benzene, styrene. So having a strong functional group, that is the acidic functional group. So this is about the cation exchange resin. Okay, now what we have to see? Anion exchange resin. Please draw it. Anion exchange resin. So similarly, it is also what? Resin having a basic functional group. In cation exchange resin, the acidic functional group, here the basic functional group are capable of exchanging their OH minus ions, mean anions, with their anion responsible for hardness. Sodium plus sodium sulfate is the hardness potential. In this anion is there. So that is the reason anion exchange resin. Here the basic functional group is there. Same like benzene, like this. It is a cross-linked polymer, long chain organic, long chain we can write. But here what is there? Negative. Basic functional group, trimethyl amine and OH minus. OH minus. This is a basic functional group. Quaternary ammonium salts. What is that? Resin is having basic functional group or capable of exchanging of OH ions with anions. Their OH ions with anion. Responsible for the anion is responsible for the hardness producing salt. These are mainly what? Styrene, divinyl, benzene or amine. Benzene or amine or formaldehyde polymers containing basic functional group such as what? Amine or quaternary ammonium groups as an integral part of a resin matrix. So after treatment of with the base, the resin become capable of ion exchange their OH minus ions. So this is about the what? This is the mainly functional group. Quaternary ammonium salt. 1, 2, 3. Quaternary ammonium salt. This is the OH minus. And everything is the benzene, styrene, divinyl, styrene. So this is what? Anion exchange resin. Here the basic functional group, here the exchanging, the OH is going this side and sulfate is coming here. So what? Sulfate and OH minus ion both are exchanged here. So that is the reason anion exchange resin. Anion exchange resin. So now what we have completed now? Just resin. What is the definition of resin? Cross-linked organic polymer having a microporous structure. Then there are the two types based on the acidic functional group and basic functional group. Acidic functional group is the cation exchange resin and basic functional group the anion exchange resin. So this is about the resin, cation exchange and anion exchange. Now the third point is the process. So process is very important. The process. In the process we have to know the diagram. The diagram is very important and it's very easy also. So diagram is Just in this, three cylinders are there. The process containing the three cylinders. Simply you have to draw three cylinders. One is the cation exchange resin filled by cation exchange resin. Another one is the anion exchange resin. So I will draw it. Please draw it. This is the first cylinder. The second cylinder. And third cylinder. This is the three cylinders. This is the three cylinders. So now it is filled by the resins. What are the resins? We have to know. It is a cation exchange resin filled. First of all, some stones. We have to use big stones. Small stone like that. Resin or sand, then filled by the resin. Filled by the resin. Filled by the resin. So what is this resin? Cation exchange resin. Cation exchange resin. And here same thing, we have to fill the sand bed. And then anion exchange bed. Anion exchange bed. This is anion exchange bed. Anion exchange resin. Anion exchange resin bed. Anion exchange resin bed. So this is the regeneration. Acid regeneration tank, and here also one tank, this tank is what basic regeneration. That is, you have to use the sodium hydroxide. Here the HCl, dilute HCl or sulfuric acid, dilute. And now water is coming, the raw water H2O is coming like this. So this is the demineralized water. Demineralized demineralized water. Demineralized water and some gases, dissolved gases. So we apply the vacuum pump here. Vacuum pump we are using. This is the diagram. So first of all, so water in the diagram, just 3 cylinders are there. Here 3 cylinders. So one is the cation exchange cylinder, another one is the anion exchange cylinder. So filled by the resin bed and some sand and bed in that. So 2 regeneration tanks are there. So this acid regeneration tank and basic regeneration tank. And this is the degasifier. What is this? This one is the degasifier. Degasifier means removal of gases by using a vacuum pump. Vacuum pump in some motor will there. Okay. And so why we are using these two down? Whenever the regeneration takes place, you are washing with the washing solution or washing compounds. Washed compounds. So this is about the diagram. Please draw it. It's a very easy. 3 cylinders. One is the cation exchange resin, and second one is the anion exchange resin and degasifier. And this is the pipelines. 2 tanks are there and filled by the cation exchange resin and anion exchange resin. Okay, just once again I will briefly explain this one. They are the what columns. The first one is a cation exchange resin column, and second one is the anion exchange resin column, and third one is the degasifier. So here the hot water, first of all, so the water containing the water, these hot waters mean calcium chloride. For example, I am telling calcium chloride, calcium sulfate. So any hot water containing the one is the cation, another one is the anion. Okay, cation anion. So listen carefully. This is the diagram. Then here the first raw water, containing the hot water producing salt, water containing the calcium chloride, calcium sulfate, any salts are there. In this, the water is first passed through the cation exchange resin. Here, the water is passed first through cation exchange column. Here, the honest producing cations, what are that? Calcium or magnesium plus 2. Taken by the resin. Just before I already explained in the cation exchange resin. So that resin is absorbed the cation, taken by the resin. The cation or cations or whatever the cations are present in the water are taken up by the resin, and equal amount of H plus ions are raised, because in this what H plus ions are the resin H plus, and here OH minus in this. So the H plus ions, the H plus are equal amount, how many calcium or equal amount of H plus ions are released into the water. Okay, the water is subsequently allowed to the second column. The second column is what? Second column is subsequently passed through the second column, that is the anion exchange column. Here the harness producing anions such as chlorides. So this resin is taken by the chloride, sulfate, whatever the anions are there, taken by the chlorides, sulfate, and equal amount of OH minus are released into the water. Equal amount. Either chlorine or sulfate or bromides or whatever may be. So this is the release of OH is released here H plus. So for example, calcium chloride present in the water. So what happened? First this resin taken the Ca plus 2. So what is there here? So equal amount of H plus is released. So in the water, so hydrogen H plus ions are there and remaining Cl minus are there. So Cl, H plus, Cl minus water. So water and Cl minus ions are passed into the second. Here the anion here taken up. Cl minus is taken, absorbed by this one. So here OH minus only released, mean H plus and OH minus. and H plus and OH minus. So what will form? Water formation takes place. This is the purification. So what is that? That in cation exchange resin column, H plus ion is released and anion exchange plus OH minus ion is released. So H plus and OH minus are combined to form the water, and this is slowly passed into through the degasifier. Here in the degasifier, this is what degasifier. So it is surrounded by the hot jackets. So here the dissolved gases such as carbon dioxide, oxygen escaped at this temperature because the high temperature is there. The temperature under reduced pressure because we are using the pump, vacuum pump. Here so almost all salts and gases are removed here. Almost all gases and under reduced pressure. So now what water will come? It's in a demineralized water. Almost all the salts and gases are removed from the water by this process is called the demineralized water. So demineralized water. Okay. So please note down this diagram. It's a very easy diagram. Okay. So then I will explain some chemistry in this one. Okay. So reactions, it's important. Reactions are more important than the theory. Okay, diagram. Please draw the diagram. It's very important. If you draw the diagram, you will get the marks easily. Then diagram, the process, whatever the process is there, you have to write. Diagram and reactions are very, very important. Without reactions, without diagram, we will not get marks anytime. Okay. So in the cation resin, that RH plus ions, okay, for example, R means resin, H plus. When the hot water, calcium chloride or calcium sulfate is there, so what happened? This is the R2Ca compound is formed plus 2H plus ion, equal amount. So this is the first equation. In case of calcium chloride, calcium sulfate, if magnesium plus is there, what happened? So magnesium plus also 2RH plus and to form the R2Mg or 2H plus. So this is the reaction occurring at cation exchange resin at cation. At cation exchange resin. Okay, anion exchange resin. Guess it. OH minus and anions like sulfates, chlorides, or whatever that. So here at anion, ROH. Anion is the what? R is the resin and OH is the anion. 2 moles of ROH ion minus. Here plus means here minus. And sulfates or chlorides, whatever may be. Sulfate, first we are looking the sulfates. Calcium sulfate or magnesium sulfate, whatever the sulfate minus 2. So what will come? R2SO4 minus. R2SO4. Resin sulfate plus 2 moles, equal amount of OH minus are released. Equal amount. In case of chlorides, ROH to form what? RH plus OH minus. RCl, OH minus. So in this all first two cases, H plus ion released at cation position and OH minus are released at anion position. Now at the end process, what is there? H plus and OH minus. H plus and OH minus to form the water. So this is the what? Demineralized water. DM water. We can say DM water mean demineralized water. So first we have seen the resin. Two types of resins are there: anion exchange resin and cation exchange resin. Then in the process diagram is very important. The diagram containing the three cylinders, cation exchange resin and anion exchange resin and degasifier. So after the process, the reactions at cations and at anions. These are the very important reactions. If you have any doubt, please ask me in phone or personal or anything. Okay. Now the final is very important. Last one is the regeneration of exhausted ion exchange resin. What is that? Regeneration of exhausted ion exchange resin. Regeneration of exhausted ion exchange resin. Exhausted one, because the resin cation taken, the cation resin, anion resin, anion taken. So almost all salts deposited in the resin. So what we have to do? We have to just here regeneration tank is there in the diagram. The regeneration of exhausted cation exchange resin column is possible by passing the dilute HCl or dilute sulfuric acid H2SO4, dilute HCl. While the other one anion and the regeneration of exhausted anion exchange resin columns possible by passing a solution of dilute NaOH solution. So this is the two tanks. One tank is arranged by HCl and another one is the base like that. So here in this reaction is important. So what we have to do here? So reaction we have to write. Okay. So what is the resin is there? The resin is this one, Ca R2A. Okay. And another anion, this is the cation resin filled by the cation and anion SO4. Okay. R2S. So this one you have to treat it with the HCl, 2 moles of HCl. 2 moles of HCl. Then what will form? 2H plus and Ca. So Ca plus 2 mean calcium chloride. So calcium chloride, this is a Cl minus and Ca plus 2 mean Ca calcium chloride washed out. Down calcium chloride. In the diagram down is the calcium chloride. When we are seeing the fresh water, then the calcium chloride will down. So in the resin containing the R2Ca treated with the dilute HCl, then in the what happened? Calcium is removed and 2H plus mean this is the RH. The resin, acid resin again formation takes place. RH. Here Ca treated react with the Cl minus and plus calcium chloride as washed out. Similarly, this one, so use the base NaOH here to form the R2OH. And plus sodium sulfate Na2SO4 washed out. Sodium sulfate. So ROH is the mean resin anion. Here cation resin. So anion exchange resin and cation exchange resin. These are what just what regeneration of exhausted ion. And finally, that sometimes may ask you advantages and disadvantages. What are the advantages are there? The process can be used to soften highly acidic or alkaline waters, because acidic is there, acid cation, alkaline is there, base cation we have to use, and it produces water very low hardness, 1 to 2 ppm, 1 or 2 to ppm So it produces the water. And so the treated water by this method can be in high pressure boilers. We can use it. And but what are the disadvantages are there? The disadvantages also there. This setup is usually very cost, because the resins are very umberlite and 120, the costly resins are there. The water should not be turbid, and the turbidity level should not be more than 10 ppm. So these are the disadvantages. Okay, finally, once again, what are the ion exchange method? External treatment of method: resin, cation exchange resin, anion exchange resin. Then process diagram. 3 cylinders are there: cation exchange cylinder, anion exchange cylinder, then a degasifier. Okay. After that, reactions: cation reactions, anion reaction. Then finally, regeneration. So regeneration means these are the regeneration reactions. Okay. So this is the total external purification of water. Okay. Thank you.